All right, let's go through questions 8 through 12 in this video. Question 8. Manish drove from Chicago to Baton Rouge. At 8 a.m., he was 510 kilometers from Baton Rouge. At 1 p.m., he was 105 kilometers from Baton Rouge. Which of the following values is closest to Manish's average speed in kilometers per hour from 8 a.m. to 1 p.m.? So first off, that is a span of 5 hours we're talking about in this problem from 8 a.m. to 1 p.m. So the question is, I'm going to write this as a ratio. In 5 hours, how many kilometers did he go? Because again, that's what they want. They want kilometers per hour. Well, he was 510 kilometers from Baton Rouge at 8 a.m. and 105 from Baton Rouge at 1 p.m. So 510 minus 105, what is that, 405? So he went 405 kilometers per 5 hours. I'm going to pull out my trusty calculator to double check that answer. 405 divided by 5, because we want every 1 hour. 81. And since we aren't on the metric system, it's a little bit tougher to make an educated guess right off the bat. If we're talking about miles per hour, probably could have ruled out the 102. All right, number 9, in the figure shown. All right, geometry problems, you can almost always just skip straight to the question when they give you a diagram. They just want to know what's the length of AC. All this other information in this problem, you really don't need to know to answer this question. So the length from A to C, and we look at these answer choices, we pretty much rule out A, B, and C. Because if this length is 16, the rest of this looks like it's bigger than 16. So it's either 42 or 48. But we quickly see a pattern here. We go from 8 to 16 on the other side. So if this side is 7, multiply that by 2, that's 14. This is 6, multiply that by 2, that's 12. Add those 3 together, you get 42. Again, geometry problems that have a diagram, 90% of the time, maybe 99% of the time, you can skip the whole problem, just go straight to the question, because a lot of this just summarizes what you can already see in the diagram. Number 10, Katerina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? So students always get confused with these because typically they divide the wrong way. Because just look at the problem we looked at previously. We did kilometers over hours, and our tendency is to think, okay, we're going to do miles divided by hours in this problem. And you'll see here in a second why that doesn't work. But first off, since we want minutes and they give us hours, let's convert that to minutes. That's pretty easy to do. There's 60 minutes in an hour. So 2.5, 2.5 times 60. We could use the calculator. 2 times 6 is 120. Half of that is 30, so that's 150. So 2.5 hours is 150 minutes. So now we got 15 miles in 150 minutes. So you can see pretty quickly, if you make the mistake of doing 15 divided by 150, you're going to get 0.1, which obviously is not a correct answer in this problem. So if you do make that mistake, just turn it around based on the answer choices. 150 minutes per 15 miles. Since they want the answer in minutes, that's why we kind of invert this. And of course, G is the answer. 150 divided by 15 is 10. Question 11. A bag contains 8 red marbles, 9 yellow, and 7 green. How many additional red marbles must be added to the 24 that are already in there? So the probability of randomly drawing a red marble is 3 out of 5. Okay, so to start, the probability of a red in this problem is 8 out of 24. There's 8 red marbles. There's 24 total marbles. You could use algebra here. I like the idea of working backwards. We need that 8 out of 24 to equal 3/5. In fact, I think I will use some algebra. We want to figure out how many additional red marbles we would have to pull to add to this 8 that are already there to get to equal 3/5. Of course, if we add X to 8, we also have to add it to 24, because if you add a red marble into the bag, you also add, you increase the total number of marbles that are in the bag. And now we are going to cross multiply. Don't know what happened there. I'm going to take 5, multiply it by 8 plus X. 5 times 8 is 40. 5 times X is 5X. Saving time here by not rewriting it with the parentheses. 3 times 24 is 72. 3 times positive X is 3X. Subtract 3X from both sides. We're going to get 40 plus 2X equals 72. Subtract 40 from both sides. We get 2X equals 32. Divide both sides by 2. 16 additional red marbles to make this equal 3/5. You could have worked it backwards. Maybe it was quicker. Since the answer choice was B, it probably was. Finally, number 12. In the standard coordinate plane, the point 2, 1 is the midpoint of CD. Point C has coordinates of 6, 8, with the coordinates of point. So if you remember the midpoint formula, it is you just take the X coordinates, you add them together, and divide by 2. And you take the Y coordinates, add them together, and divide by 2. And we could do this, although this one's a little tricky because they give us the midpoint. And they give us one set of the endpoints here. So essentially what we're saying is we're taking the 6 and we're saying, okay, what do we add to it? And then divide by 2 to get our X coordinate up here of 2. So 6 plus what divided by 2 equals 2. And this one I think we could work backwards. So we take -2. We substitute X for -2 there. 6 plus -2 is what? 4. And 4 divided by 2 is 2. Okay, so it's either F or G. Let's check G, because this number is going to be a lot easier to check than the -7/2. So I'm going to take my Y coordinate of 8, and we're adding some number to it, dividing it by 2, and it should equal this number 1. So 8 plus, let's just write over 8 plus -6, or 8 minus 6 is 2. 2 divided by 2 is 1. So G is our answer.